All right, so with the transformations of functions, that's when you have your original function and then there's adjustments made to it, which often happens. We never deal with just the base functions. All right, so just given any function, y equals f of x, the transformations applied to the function can be written in the form y equals a, which is a variable we have to worry about, times f. Now, f is just the function, so f doesn't mean anything to us other than the fact that it's function notation. But then we have a k in brackets x minus d square brackets plus c. Okay, so we're going to deal with a bunch of these. But so, for example, an exponential function. Now, an exponential function, the base function, would be written in the form just simply y equals b to the power of x. All right, that's just the base function. But then you have this value of a can be in front. We can have a k up here and in the exponent. We have an x minus d plus a c. All right, now we're going to talk about a couple of things, and that is the a value in front. That refers to a vertical stretch or compression, or possibly a reflection over the horizontal axis or the y-axis. Or sorry, that should say the x-axis. Sorry. There we go. All right, now your k value, and when you're talking about a vertical stretch or compress, vertical's up and down. So compression is when you're smushing the graph. It looks like it's smushed from the top and the bottom, where a stretch looks like you pulled it from the top and the bottom. This k value, which you probably haven't dealt with yet in math, is where you got the opposite, where you have the horizontal stretch or compress. So left and right, you're stretching it. The graph looks like you're pulling it from the left and the right, or you're pushing it in from the left and the right. You can also have a reflection over the vertical axis, which is a nice way of saying the y-axis, which I'll use. All right, now we also have a horizontal shift. So that's dealing with left and right. All right. And you have your vertical shift. Vertical is, in other words, it's talking about your up and down, what's happening. Now, a couple of things I want to talk about with these letters. The first one is with your a value. If your a value is negative, then you have what's called a flip over the x-axis. All right, it's been flipped over the x-axis. With a k value, if it is less than 0, then you're flipping it over the y-axis, your graph is. All right, and when you have a horizontal stretch and compression, we talk about it being by a factor of 1 over the absolute value of k. And so what happens is if k is, I should say the magnitude of k, or the absolute value of k, is greater than 0, that's when it's a compression. You have a horizontal compression. Can't fit that all in here. And if the absolute value of k is less than 0, you have a stretch, a horizontal stretch. And we're just going to need to know that information for the language we're going to use. All right. Now, that's in terms of the language. Now, what we're going to be doing is using points and then actually finding these points, the translation or the transform, the new location of these points. And so what we have is our two formulas here. We have a formula for the x2s, which is your new location of your x coordinate, and we have y2, which is the new location of your y coordinate, where x1 and y1 are the old locations. And again, we'll get to that and how that works. But here's the two formulas we're going to be using today. Not right away, but it's coming. All right, so here we go. In words, describe the transformations that have occurred to the following parent functions. All right, so here's what we got here. First off, we have the parent function is y equals x squared. Now, you have to be able, this is the hard part, is picking out what values you actually have. Now, in this case, our a value is always in front of the function. All right, so there's our a right there. Now, we have a k value, but you can't really see it because really this function looks like this. How am I going to write it out? Y equals, so this is kind of what it looks like. Well, it does look like 5, but we have a bracket. Whoops, I need a good bracket. Bracket 1, then another bracket x plus 2, squared to the power of 2, square bracket minus 4. That would be another way to write this thing. The thing is that just because k is 1, we don't bother, all right, because it doesn't change anything. All right, now inside the brackets, we have a positive plus 2. Now I'm going to get to that. I should have went back to, I'm going to go back here. Notice there's a minus sign in front of this d here. Okay, it's supposed to be there. All right, so we're going to deal with that. So that is our d value in here. All right, now afterwards is our c value. Now here's the thing. Is first off, it says in words describe the transformation. Now I see that my a value is 5. So that means I have a vertical stretch, as it's greater than 1, of 5. Oh, by a factor of 5, I should say. All right, now, because my k value is 1, I don't have to talk about anything there. Nothing special is going on. And that's why this is written the way it is. Now my d value. My d value, again, is about the horizontal shift, the left and the right. See how there's a plus sign? Not supposed to be. It's supposed to be a minus sign. So this is actually telling me that this graph is shifted left to. All right, so it looks the opposite. That's the trick of the horizontal shift. Should be a minus sign there, but there's not. So that means it's actually a -2 is my d value. My d is actually -2. All right, and that's going to come into play here when we start using my graph. All right, and then the c value is normal. So that controls your vertical shift. That's the up and down here. It's -4, so this graph is going to be shifted down 4. And there we go. So that's all that's going on with this transformation. I won't say that all that's going on. It's quite a bit, but again, that's the factor. All right, now we get to the next one. B, our parent function here is the absolute value. All right, now it's undergone some transformations. Now see, we got a negative sign out front. That's really telling me that a is -1. That is my a value there. All right, my k value, again, it's inside the function and it's multiplied by the thing in brackets, so we do have a k value. And then inside the brackets, within the function, that's our d value. And then our c is afterwards, which, well, you can see what's happening there. All right, so now to describe in words is what's going on. Because the absolute value of my a value is just 1, there's no vertical stretch or compression, but it is negative. And so that means what I have is a reflection across. That means it's flipped. That's what a reflection is all about. So it's a reflection across the x-axis. That's what that negative sign is talking about. Now the k value, now here's something weird, is 2. But remember that when we're talking about stretches and compressions here, go back to my note here, it's by a factor of 1 over the absolute value of k. So if k is greater than 0, we have a compression. K is less than 0, we have a stretch, the magnitude. All right, so in this case, whoops, because the k value is 2, I'm going to write that there is a horizontal compression by a factor of 1 over 2. There we go. So that's a little bit different than how the a value works. So that's the kind of the two tricks today, is working with the k and working with the d. Everything inside, right? Because again, the d value here, see how I have a 5 there and I have the minus sign? Well, the minus sign is supposed to be there. And again, the d is all about the shifting, horizontal shifting. So this is actually shifted right 5. All right, and then the c value, well, there's nothing there, and so that means this thing is not shifted up or down. All right. Now let's get to the next one. Now we didn't do the sine function graph it, but all we have to do is be able to spot our values here. All right. So again, with the a value, that's always the value in front of our function. So there's a. K is within the function, but in front of the brackets. So there's my K. My D is inside the function, inside the brackets. And then the C value is on the outside. All right, so let's deal with the wording first, the A value. It's a 3. So this thing is being vertically stretched by a factor of 3. All right, now to deal with the K value. Now, when I look at the factor of K, K is negative 1/4. I'm just looking at the absolute value here. And the absolute value of K, I might have messed a part of my note up here. I'm going to have to fix it, is equal to 1/4. Now, when I talk about the factor, it's 1 over the absolute value of K. All right, so I got 1 over 1/4. Whew. Now, how you divide by a fraction is you invert and multiply. So that would actually be 1 times invert the fraction. And so 1 times 4 over 1 is 4. And so our K, well, is it should be, I messed a part of my note up there, folks. I have to fix it. Is greater than 1. And so this thing is going to be vertically stretched, or sorry, not vertically. K is horizontally. Got to watch that. Horizontally stretched by a factor of 4. Again, K works a little bit differently. Here's my part of my note where I messed up, and I apologize for this. Right here, down, where's my little, rub this out. It shouldn't be a 0. It should actually be a 1. There we go. All right, so it's less than 1. We got to stretch because when I do my 1 divided by the absolute value of K, I get 4. All right, so again, apologize for that. All right, now dealing with the D. Again, that minus sign is supposed to be there. So that's, again, the horizontally shifting. It is shifted right 1 then. And then I look at my C value. It's just a +6. It's straight up, so it's up 6. And there we go. So there is, in words, describing what is going on with these functions and their transformations. All right, now, example 2. This is where we're going to get into using the equations that I have. So I'm going to go back to those real quick. Now we're going to start to use this equation right here. And you know what? I wonder if I can just copy this. Whoa. Come on, I'm doing my pointer here. See if this works. There we go. It's not going to work. All right. Anyways, those are the formulas we're going to use. I'll have to write them out. All right, so here's the point we're going to transform. -4, 10. It's on the graph of our original function. Okay, we don't know what that function is, but we know that point's on it. So what this is telling us in our equation is this is the x1, this is the original x coordinate, and this is the y1. That's the original y coordinate. And what we want to find out is the new coordinates. All right, so that we're looking for the new x2 and y2, where these this point gets transformed to if this graph, f of x, goes through these transformations. Now, the formulas, I'm going to get to those, but I'm going to draw a little table here. I wonder if I can move this down. I did the whole thing. All right. All right, so first off, the a value is usually the number in front. Well, there's just a 1 in front. It's an invisible 1. So I like to write down my a values, or my values in general here. So a is equal to 1. All right. My k value, again, is inside the function, but in front of the bracket. So k is equal to 4. All right. My d value inside the brackets, but again, it always looks the opposite. So d is actually 6 because the negative sign is supposed to be there. And then the C value comes after. I don't see nothing. So C is 0. All right. So now when I find my new points, here's when I'm going to use my equations here. And I totally don't have enough room here. I'm going to be honest with you. All right. So I've got x2 is equal to, using my equation here, I'm going to write it out first, x1 divided by k, all right, plus d. So that means the new x coordinate, where it's going to be transformed to, again, my x1 was the original. It's -4. It's a -4 there. K is 4. All right. And my d is 6. So I got a +6. And so I take -4 and divide it by 4. I get a -1. +6, 5. So that x coordinate is the new one's going to be 5. Now I got to find the y values. I'm going to use a different color here. I'm going to use my formula again that I had there, which was y2 is equal to, what was it here? A, just looking off my sheet here, times y1 plus c. All right, now I'm not going to do this one here. I'm going to just do c. So let me see. y1 was 10. A here is 1, so I'm going to have 1 times my y1, which is the 10, and c was 0. Well, that's not hard to find. There we go. Well, I guess 1 times 10 plus 0, that's just going to be a 10. And so what this is saying is that my new coordinate of the transform function, on the original graph, it's -4, 10. And on the new one, it's going to be 5 was our x coordinate, and 10 was our y coordinate. And there we go. All right. So now I'm going to get to C here. I'm going to skip B, go to C. I wonder if I can move that down a little bit just so it gets messy. Oh, yeah. There we go. Okay. So now the new one. So again, I'm still dealing with my original point there, which was -4, 10. My original point. But now there's a new transformation. Here it is. Bunch of stuff going on. But again, I got to find my values. All right. So again, A is the number in front of the function, which is -3. All right. K is inside the function, but in front of the brackets, it's 1/4. All right. D is also inside the function. Now, again, it looks the opposite. There's a plus sign there. So that means my D is -1. This thing's being shifted left 1. And my C is -3. All right. So again, I'm going to use those same equations that I did before to find where the new transform point is. All right. So I got x2. I'm going to write it out again just because helps out. x1 divided by d. All right. Oh, sorry. x1 divided by k. Ah, man, that sucks. All right. x2. It's killing my hand here with the mouse. x1 divided by k. So I can't make a mistake. Plus d. All right. So I substitute in. So again, x1 was our -4. Pop in a -4 there. K is 1/4. So we're going to have to divide by a fraction. All right. And then D was -1. All right. So I keep. Get rid of this. All right. So again, when you're dividing by a fraction, you invert multiply. So I'm going to have -4 times 1/4 becomes 4/1. Which is just 4, really. And then I have this -1. All right, so then I can do this all in one step. Let's see here. -4 times 4, which is -16, -1, -17. All right, so there's my new x coordinate. So now I got to go and do the y coordinate. All right, so again, I'm going to use my formula up there, which is y2 is equal to A times y1. And again, plus C. Okay. So I've got my values here. So y2 is equal to, let's see, A is -3. My y value here is 10. And C is minus 3. All right, well, let's see here. Minus 3 times 10 is minus 30. Minus 3 is minus 33. And so my transform point, if I had the point negative 410, and on this function, it goes through a heck of a lot of transformations, I could replot that point, which we're going to do here shortly, as minus 17, minus 33 is where that new point would be located. The corresponding point, I should say. All right. Now, we're actually going to put this into use. Here we go. Graph y equals 2 to the power x. So that's that exponential function I've been talking about. And its transformation using at least 3 points. All right. So I'm going to pick one positive point, one negative point, and one negative x value. One negative x, one positive, or neutral x, one positive x. Hopefully I said that before. All right. So one of the points would be if I put in a minus 1. Let's see. I put a minus 1. 2 to the minus 1 is actually 1/2. All right. We're going to figure out the transformation here. All right. Another point I put in x equals 0. And 2 to the power of 0 is just 1. So this is for the original graph here. I'll underline that in red so you know. I'll do different colors here. All right, and then one positive point. So let's go with 1. 2 to the power of 1 is 2. All right, so I'm going to graph this. This is my original function here. So I got negative 1 to 1/2. Right there. All right, 0, 1. It's right there. And 1, 2. All right, this is an exponential equation. So it starts off rising slowly and then takes off. Okay. So there's my original graph. Now this graph undergoes a transformation here. And so I'm going to write down all the values here. All right, of this transformation. Again, A is the value in front. That's 2. All right, K is inside the function, but yet in front of the brackets, and it's negative 1/2. D is inside the function. Got to watch out. Always looks the opposite. It's a positive 1 because that negative sign is supposed to be there. And C is a 3. There we go. All right, so now I'm going to have to do this a little quicker because now I'm going to use my equations here. Let's see, I'll write it up. Whoops, up here. X2, right, is equal to X1 all over K plus my D value. All right, and I also have, I'm going to find Y2 is equal to A times Y1 plus C. Now, here's the thing is I got 3 different points I'm starting with. That means I'm going to have to use these equations 3 times, right? So I have an X, an X1, an X1, and an X1. I got 3 X1s and 3 X2s. So we're going to come up with, 3 X1s and 3 Y1s. So I'm going to come up with 3 X2s and 3 Y2s. Man, a lot of tongue twisters today. All right, so here we go in terms of calculations. So my first point, I got a Y1, an X1 here of negative 1 divided by K, which is negative 1/2. Yikes. Plus D, which is plus 1. All right, now the Y coordinates. I have A, which is 2 times Y2, which is 1/2. And then my C value plus C is plus 3. So I'm figuring them all out at the same time here. All right, so quick math here. Negative 1 divided by negative 1/2. First of all, the negative signs are going to cancel each other out, so it's going to be positive. And then let's see here. If I invert that fraction, or you can just use your calculator here, negative 1 divided by negative 1/2 is actually 2 plus 1. 3. All right, and then this one here, I got 2 times 1/2, which is just 1, plus 3, 4. So this point transformed is going to be 3, 4. So 3 to the right, up 4. There's 1 point on my transformed function. All right, let's do the other one here. Same formula I'm using. All right, back to the same formula. So I have my new x1, which is a 0, divided by k, which again is -1/2, plus 1, which is our d value. All right, comma. All right, then I have my a value 2 times y1, which is now 1, plus 3. All right, so just doing a little quick math here to figure these out. Whoops, it's 2 times, I got to do this all over again, plus 3. All right, there we go. So what happens when I make a mistake, it erases a bunch. All right, so my next value here, let's see, figure out my k. 0 divided by anything is 0. Plus 1, we got a 1. All right, then 2 times, now I'm figuring out the y coordinate here. 2 times 1 is 2, plus 3, well, that's 5. All right, so my new transform point is going to be 1, 5. I'm just doing different colors so you can follow along. All right, now our last point, again, substituting into the formula once again. I got my new x1, which is 1, divided by the k value, which is -1/2. All right, plus 1, which is our d value. Comma here, let's see here. I got 2 times my new y1. My new y1 here is now 2. Plus c, which is still 3. The a's, the k, the d, and the c is not changing. It's just my new x1 and my y1s are changing. That's it. All right, little quick math here. Again, you could type in your calculator 1 divided by -1/2. Let's see. 1 divided by -1/2 would be -2 plus 1. I'm going to get a -1 here. All right, and then, well, 2 times 2 is 4, plus 3 is 7. Bingo. All right, so my new point was -1, 7. -1, 1, 2, 3, 4, 5, 6, 7. All right, so we only did 2 or 3 points, but here's your new transform graph is roughly going to look like this. New transformation. And there we go. Now, one thing I want to show you is you see our k value here, because I like to show this. See how it's negative? That means we have a reflection across the y-axis. And see how this graph has been flipped. You know, there's a lot of transformations going on, but just to talk about that specific negative sign, that's how that graph has been flipped across the y-axis. So that's just an example of that going on. All right, so there is, again, the transformations of any function.